Hi friends, welcome to Talent Sprint's Banker's Choice program. In this session, we are going to discuss one of the foundation topics from quantitative aptitude, that is number systems. The main aim of testing the numerical ability of a candidate in various competitive exams is to see if the candidate can perform various mathematical operations or calculations. So that is the reason the knowledge of numbers and number systems is very essential for a candidate who wish to appear for various competitive exams. So in this session, we are going to discuss all about the number system and the various types of numbers that we use in all these operations. A number system is a collection of various symbols which are called digits. The number system that we follow is called decimal number system, where the base is 10. The base is 10 indicates that there are 10 different symbols in decimal number system. So let us understand what are these 10 symbols. So the number system that we follow is decimal number system, as I've mentioned, and the 10 symbols that we have here are 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. These 10 symbols are also called as digits. So these are the 10 digits which we use whenever we form a number. Any number that we make is a combination of any of these 10 digits. For example, the number 486 is nothing but a combination of 4, 8 and 6. Similarly, let's say the number is 1486. Now this is a combination of 1, 4, 8 and 6. So whatever numbers that we use in our calculations are all made up of any of these 10 digits. Why? Because we follow the decimal number system. Like decimal number system, there are various other number systems. For example, there is something called as binary number system. A binary number system is a system which has got a base of 2. It has got only two symbols, 0 and 1. So whatever numbers that are made in binary system are only with a combination of zeros and ones. Likewise, the other number system is octal number system, which has got 8 different symbols from 0 to 7. And then there is hexadecimal system, which has got 16 different symbols. Of these, 0 to 9 are the first 10 digits, and then A, B, C, D, E, F are the remaining 6 symbols. Now in all these number systems, the numbers that are made are only of the combination of the digits which are present in that system. So whatever numbers that we make in decimal number system should always be a combination of these 10 digits. We cannot have anything other than these 10 digits. Now, as I have already mentioned, the base of decimal number system is 10 because we use 10 different symbols here. So this number 1486 can be represented as 1000 plus 400 plus 80 plus 6. The reason behind this kind of representation is because we are using different digits, that is 1, 4, 8 and 6, and each of these digits has got a place value depending on its position. For example, 6 here is in units place. This is called as units place. Then 8 is in tens place, 4 is in hundreds place, and 1 is in thousands place, and so on. That means the first position from right hand side is units place. It is referred as units place or ones place. That means its positional value is 1. The second position is referred as tens place. That means whatever digit is present there has to be multiplied with 10. The third one here is hundreds place. So whatever digit is present in hundreds place has to be multiplied with 100. Why? Because its positional value or digits value is 100. And similarly, 1 is in thousands place. So that is the reason the correct way of taking the number here would be 1000 plus 400 plus 80 plus 6. That is nothing but 1 into 1000 plus 4 into 100 plus 8 into 10 plus 6 into 1. That means we have 6 in units place, 8 in tens place, 4 in hundreds place and 1 in thousands place. So this is how a number is represented in decimal number system. For example, let's say the number is 24. 24 should be taken as 2 into 10 plus 4 into 1. Why? Because we have 4 in units place and 2 in tens place. So the basic representation of a number in decimal number system has to be done with the place value as 10 power 0, 10 power 1, 10 power 2 and 10 power 3 and so on. 10 power 0 is nothing but 1. So that is why it is called as units place. 10 power 1 is 10. 10 power 2 is 100, 10 power 3 is 1000 and so on. So from this we can understand that the representation of any number in decimal number system should be in terms of powers of 10 starting from 0 from right hand side to left hand side. So any two-digit number AB can always be represented as 10A plus B. Why? Because it is A in tens place, so it should be multiplied with 10, and B in units place, so that is multiplied with 1. So a two-digit number AB should always be represented as 10A plus B. Similarly, a three-digit number ABC should be taken as 100A plus 10B plus C. So this is how we represent the numbers in case of decimal number system. And since bank exams test about only the knowledge of decimal number systems, we are going to restrict our discussion only up to this number system. And we shall not discuss about various systems like binary number system and octal number system and so on. So the most important point to be understood here is the representation of numbers in case of decimal number system. Let us now understand how the numbers in case of decimal number system can be classified. The point here is we have got only 10 digits, but the numbers that are there in decimal number system are infinite, and all these infinite numbers are made up of a combination of these 10 digits, as I've already mentioned. Let us now look at the classification of numbers into various types. The first one here is natural numbers. Natural numbers are those numbers which are used for the purpose of counting. It is a set of positive counting numbers and denoted by the letter n. As you can see here, natural numbers include 1, 2, 3, 4, 5 and so on up to infinity. The next one here is whole numbers. Whole numbers is a set of all the natural numbers including 0. It is generally denoted by the letter W, and as you can see, the set here consists of 0, 1, 2, 3 and so on up to infinity. The next one comes here as integers. Integers is a set of all whole numbers along with the negative numbers. As you can see, in the previous two cases we did not have any negative number. All the numbers were positive. But now integers also include negative numbers along with the whole numbers. Generally denoted by the letter I, this set consists of the numbers starting from negative of infinity and then coming up like -3, -2, -1, 0, and then positive integers 1, 2, 3 and so on up to infinity. So as you can see, it is a set which has got all the whole numbers along with the negative numbers. So all such numbers are referred as integers. Then the next classification here is even numbers and odd numbers. Even numbers, as we know, are those numbers which are exactly divisible by 2. This is a set of numbers that is exactly divisible by 2, or we can say these are the exact multiples of 2. So 2, 4, 6, 8 and so on are the examples of even numbers. Why? Because these are the numbers that are exactly divisible by 2. The next one is odd numbers. Odd numbers are those numbers which are not exactly divisible by 2. So set of numbers which are not exactly divisible by 2 is referred as odd numbers. Or we can say numbers which are not even are odd. So 1, 3, 5, 7 and so on are the examples of odd numbers, as all these numbers are not the exact multiples of 2, or these numbers are not divisible by 2. So if a number is divisible by 2, it can be taken as even, otherwise it is to be considered as an odd number. Let us now understand what is meant by real numbers and the classification of these real numbers. These are the numbers which represent the actual physical quantities like height, weight, density, etc. in a meaningful figure or a meaningful number. Now these are basically classified as rational numbers and irrational numbers. So real numbers are those numbers which we use in the physical world to measure various things like height, weight, etc. So this comes out as a meaningful figure or a meaningful number. And the basic classification of real numbers is rational numbers and irrational numbers. Now rational numbers are those numbers which can be represented in the form of A by B. As you can see here, these are the numbers which can be represented in the form of A by B, where A and B are integers and B should not be equal to 0. So as we can understand from this definition, rational numbers can be expressed in the form of a fraction, that is A by B, where the denominator B should not be equal to 0 and A and B have to be integers. Now some examples of rational numbers here are 1 by 2, 3 by 4, 7 by 12. As you can see, these are all in the form of A by B. And at the same time we can also have negative fractions. That doesn't make a difference. So 1 by 2, 3 by 4 or minus 3 by 4, minus 7 by 12 or minus 1 by 2. All these are examples of rational numbers. Similarly, 8 again is also a rational number. Why? Because 8 can be taken as 8 by 1. Similarly, minus 6 can also be taken as minus 6 by 1. So from this we can understand that all the integers are also rational numbers. Why? Because all integers are like fractions where the denominator is 1. So we can say that even integers are rational numbers. And likewise we have 1 by 3, 1 by 7, 2 by 9, etc. These are all the examples of rational numbers. Next comes irrational numbers. Irrational numbers are those numbers which cannot be expressed in the form of a by b, where b is not equal to 0. So we can say that numbers which are not rational are irrational. So as you can see here, these are the numbers that are not rational in nature and cannot be expressed as a by b, where b is not 0. So all those numbers which cannot be taken in the form of fractions should be considered as irrational numbers. And some examples here are root 2, root 3, pi, etc. Right? So from this we can understand that all the square roots of imperfect squares comes under irrational numbers. For example, root 5, root 7, root 8, all these form a part of irrational numbers. Let us understand what is the actual difference between rational and irrational numbers with the help of these examples. Now if you try to look at these fractions, 1 by 2 can be taken as 0.5 or minus 1 by 2 can be taken as minus 0.5. Similarly, 3 by 4 or minus 3 by 4 is minus 0.75. Likewise, minus 7 by 12 can be taken as minus 0.58333 so on up to infinity. Then 8 by 1 is nothing but 8.0, minus 6 by 1 is minus 6, 1 by 3 we know is equal to 0.333 so on up to infinity, and 1 by 7 would be 0.142857 and 142857 and so on. And likewise 2 by 9 here would be equal to 0.222 up to infinity. So from all these examples, after converting them into decimal part, you can understand that all the rational numbers are either terminating or non-terminating. That means if you look at 0.5, it is a terminating number. The numbers after the decimal ends at some point. Similarly here again, the numbers after the decimal point ends at some particular point. And in case of 8.0, minus 6.0, the numbers end after the decimal point. So these are referred as terminating numbers. And the other numbers are referred as non-terminating numbers. That means after the decimal point, the number never ends. It goes up to infinity. As in the case of 0.58333 up to infinity, or 0.33, or 0.22, or like 1 by 7, 0.142857. So these numbers never end. They go up to infinity. So these are referred as non-terminating numbers. So every rational number is either terminating, like in this case, or non-terminating, as we can see here. Now in this non-terminating numbers, we find that there is some part of the number which appears at regular intervals. It occurs again and again. For example, if you look at 0.333, here this is nothing but 0.3 bar. That means this digit 3 or this number 3 occurs again and again at regular intervals up to infinity. Similarly, in case of 0.22, it can be taken as 0.2 bar. Why? Because here the number 2 occurs again and again at regular intervals. And if you look at 0.58333, up to 5, 8, it is fine, but after 8, the number 3 goes on up to infinity. So this can be taken as 0.583 bar. That means 3 again occurs again and again at regular intervals. And in this case, we find that 142857, the set of these 6 digits occurs again and again up to infinity. As you can see, this is 0.142857, 142857, and 142857, so on. So the point to be observed here is, as we have discussed, rational numbers are either terminating or non-terminating, but in case of all these non-terminating numbers, we find that a particular set of numbers occurs again and again, or they reoccur, or we can say these are recurring numbers. That means they occur again and again at regular intervals up to infinity. So very clearly, rational numbers are either terminating or recurring. Why? Because all these non-terminating numbers are recurring in nature. So that's the basic idea about rational numbers. These rational numbers either terminate at some point, or if they are non-terminating, they recur in nature. That means they are recurring numbers. Let us now understand the basic idea behind irrational numbers. Now, as we have seen, the examples are root 2, root 3, pi, etc. Now, if you look at root 2, the approximate value of root 2 is 1.414. Similarly, the approximate value of root 3 is equal to 1.732. That means in case of irrational numbers, we never get an exact answer. We can always talk about an approximate answer in terms of decimal or fractions. The point to be observed here is root 2 or root 3 here. That means irrational numbers are non-terminating in nature. That means these numbers after the decimal point goes up to infinity. And at the same time, they are non-recurring in nature. That means there is no particular digit or no particular set of numbers which occurs again and again at regular intervals. So the numbers which are non-terminating and non-recurring are called as irrational numbers. So that is the basic difference between rational and irrational numbers. Rational numbers are either terminating or recurring. So we can understand that rational numbers are either terminating or recurring in nature, whereas irrational numbers are non-terminating and non-recurring. Non-terminating and non-recurring. That means they neither terminate nor do they recur. So such numbers are referred as irrational numbers. After learning about rational and irrational numbers, let us now understand what is meant by factors and multiples. If a number x divides y perfectly, then x is considered as a factor of y and y becomes the multiple of x. So as given here, when a number x divides some other number y perfectly, what does it mean by perfect division? A perfect division is the one where the remainder is 0. So in such cases, the number x is referred as a factor of the number y and y is called the multiple of x. For example, 4 is a factor of 16. Why? Because 4 can divide 16 exactly. 16 by 4 is equal to 4. The remainder is 0. So that is the reason 4 is considered to be a factor of 16. And hence 16 becomes a multiple of 4. Why? Because if x is a factor of y, y has to be the multiple of x. Similarly, 18 is a multiple of 16. Why? Because 18 is divisible by 6 exactly. So if 18 is divisible by 6, that means 6 is able to divide 18. So if 18 is multiple of 6, we can say that 6 is a factor of 18. So very clearly factors and multiples are linked to each other. If A is a factor of B, then B has to be a multiple of A. So if 4 is a factor of 16, 16 is a multiple of 4. Apart from 4, the other factors of 16 are 1, 2 and 8. Why? Because 16 is exactly divisible by all the three numbers. 16 by 1 is equal to 16, 16 by 2 is equal to 8, 16 by 8 is equal to 2. So only those numbers which can exactly divide the given number should be taken as the factors of the number. And similarly, only those numbers which are exactly divisible by the given number should be considered as multiples of the number. For example, apart from 18, the other multiples of 6 are 6, 12, 24, 30 and so on. Why? Because all these numbers are divisible by 6. So factors are those numbers which can exactly divide the given number and multiples are those numbers which are exactly divisible by the given number. Based on the number of factors, all the natural numbers except one can be classified as either a prime number or a composite number. So let us understand this important differentiation between prime numbers and composite numbers. Prime numbers, these numbers have no factors besides 1 and itself. So prime numbers are those numbers which have only two factors, 1 and the number itself. And some examples of prime numbers are 2, 3, 5, 7, 11 and so on. So all these are the numbers which have only two factors, 1 and the number itself. For example, the factors of 2 are 1 and 2. Factors of 3 are 1 and 3. For 5, 1 and 5. For 7, 1 and 7. These numbers are divisible only by 1 and by the number itself. No other number can exactly divide such numbers. So these numbers are called as prime numbers. Next comes composite numbers. Composite numbers are the numbers that have other factors beside 1 and itself. So the numbers which have more than two factors are called composite numbers. For example, 4, 6, 8, 9, 10, 12. So we can say that all the numbers other than prime numbers can be taken as composite numbers. For example, 4, the number of factors of 4 are 1, 2 and 4. So we can see that there are more than two factors. Apart from 1 and the number itself, 2 is also a factor of 4. Why? Because 2 can divide 4 exactly. So 4 cannot be a prime number as it has more than two factors. So it is called a composite number. Similarly, when you look out for all the other numbers, they have more than two factors. The factors of 6 are 1, 2, 3 and 6. For 8 we have 1, 2, 4 and 8. For 9 we have 1, 3, 9 and so on. So all these numbers have got more than 2 factors. So they are called as composite numbers. One important point to be observed here is the number 1 is an exception. It is neither a prime nor a composite number. 1 does not participate in any of these 2 categories. So except 1, all the remaining natural numbers can be classified either as prime numbers or composite numbers depending on the number of factors which they have.